This product is legal in California for racing vehicles that shall never be operated upon a public highway. AEM holds no responsibility for any engine damage that results from the misuse of this product. Before we configure the setup menu, let's first discuss why you use a MAFClamp. The main reason is to keep the ECU from seeing boost. We are spoofing the MAF function to keep the ECU from thinking there's a problem because it's now seeing boost when it was originally never meant to. Also, the MAF influences fuel control in the ECU. For better fueling management in boost, we want the FIC to take over fueling, not the ECU. Now, to begin, open the Setup System menu, and in the MAF section, make sure the load input is set to MAF, the mode section is set to voltage, the max voltage clamp is the highest MAF voltage the FIC will output. In this setup, we will leave it at 5. The next step is to gather the appropriate MAF info from data logs. Use the FIC's internal logger to record a series of high-load, wide-open throttle runs. Keep in mind this needs to be done on a stock vehicle in order to correctly spoof the MAF function. Once you've recorded your logs, import them into the AEM log software for viewing. Please see additional videos on how to import FIC logs into AEM log software. Set your logs to show MAF, RPM, and engine load. Viewing throttle position may also be helpful. When viewing your logs, try to find an area where the motor is in high load at wide open throttle and RPMs are increasing relatively slowly. This would most likely be in a long, high gear pull from almost idle all the way to redline. Look at the log to determine your minimum and maximum MAF voltages. Now, move this information to the MAF map in the FIC. Leaving the lowest cell on the y-axis scale at 0, set the second lowest cell to your minimum MAF voltage and set the highest cell to your maximum MAF voltage. In this case, we're using 1 volt for a minimum and 5 volts for the maximum. Calculate between the two values to fill in the rest of the scale. Now, copy and paste your voltage scale across the entire MAF map. An easy way to do this is to paste the column into the left and right sides of the map and then calculate across. When you do this, be sure not to include the zeros in the lowest row as they will change the table values. To set the MAFClamp values, look at each RPM breakpoint listed on the MAF map and find the corresponding MAF voltage on your log. In this example, 700 RPM had a MAF voltage of about 1.5 volts, 1000 RPM had a MAF voltage of about 2 volts, 1400 RPM had a MAF voltage of 2.3 volts, and so on. Now find this voltage on your MAF map. The first area is 700 RPM and 1.5 volts. Once you've found the appropriate cell on your MAF map, move up one cell on the column. Select this cell and the cells above it all the way up to the top of the map. Right-click, select Set Value, and enter the MAF voltage clamp value, in this case 1.5 volts. You have now clamped the MAF voltage for this RPM breakpoint. You can also select the clamped area, right-click, select Change Value, and increase the clamped voltage by a small percentage, say about 5%. This adds in a buffer that allows for variances in air density. Continue this procedure of finding MAF voltages in your log for each RPM breakpoint listed in the X-axis RPM scale of the MAF map. Input the clamped MAF voltage values across the entire MAF map. This graphic shows the clamped boost area in red. Now that you've completed your MAF map with clamped voltage outputs, test your vehicle and make the appropriate changes needed to make the vehicle run smoothly. Remember, the objective of the MAF clamp is to keep the ECU from seeing boost. This will keep the ECU from throwing a code or going into limp mode, and will also allow the FIC to manage fueling, which is much easier for you to control.